Lesson 10.3 is entitled Triangles. So we're talking about triangles a couple of different ways. First thing is measures of the angles of a triangle. And the three angles of a triangle always add up to 180 degrees. So part of the problems that you're going to be dealing with is finding missing information or missing angle measures, and this is what I'd like for you to do. Since all three angles add up to 180, you should set up an equation. Okay, so I'm going to ask that you definitely set up an equation, even though you could probably do it without, but for those that you can, I want you to practice it. So this particular problem that we're looking at in the first example, it has an angle that's 33 degrees, one that's 100 degrees, and one that is x. That's the one that's missing. So we would definitely go 33 plus 100 plus x and set that equal to 180 degrees. So when we're solving equations, if there are like terms on the same side of the equal sign, we combine them. So 33 plus 100, 133 plus x equals 180. And how would we solve for x?
180 minus 133.
Yeah, you'd subtract 133 from each side. And x would be 47 degrees. And that's what I'm going to ask that you do. It's just practice in writing equations from problems. That would be good practice for I-STEP. There might be some that maybe have a couple of things missing and a couple of x's, and you might have to combine that. So it would be just good practice. Add up all three angles, set it equal to 180, and solve that equation. Any questions about that? So those you've probably had a little experience with. This next part, probably not so much. This one is not giving you the exact measures. It's telling you something about the angles of the triangle, though. It says the measures of the three angles of a triangle are in the ratio of 2 to 3 to 5. It's not telling you what any of the measures are, but they're in that ratio. What are the measures of the angles? Okay, so what this is saying is 2 parts, 3 parts, 5 parts. You just don't know what that part is. So the first angle is 2 parts. I'm going to put 2x to represent that. The second angle is 3 parts. So I'm going to add 3x, 3 parts. And the third angle, I'm going to add that as 5 parts or 5x. And we know that 3 angles always add up to 180. To solve this, you have to think 2x plus 3x plus 5x. So adding all that up, 10x equals 180. How would I solve for x on this one? Tori? Divide each side by 10. So x equals 18. And that's good to know. It's just saying that the part is 18, but it's not really telling you about the angle measure. So what you've got to do is you've got to go back and say, okay, my first angle, that's 2x, it's 2 times 18, 36 degrees. The second one, that's 3x, it's 3 18 degrees, 54. And the last one, 5x, it's 5 times 18 degrees, 90. So you have your 3 measures, 36 degrees, 54 degrees, and 90 degrees. Questions about that? You definitely need to set up an equation. You need to use a variable for the part. Use the ratio of each one times that part and set it equal to 180. Questions about that? This part, I'm hoping, is just a review. talking about angle measures and their names. So acute angles are less than 90 degrees. So basically 1 to 89 is really what that fits, is less than 90 degrees. Right is exactly 90, and if you're seeing it in a picture, almost all the time they'll put a little box in the corner, and that definitely means it's a right angle. It's at exactly 90 degrees. Obtuse is between 90 and 180. So really 91 and 179. 191 to 179. Once you get to 180, that's called a straight angle, and it's really a straight line, but it's also called a straight angle. So acute, right, obtuse, and straight are the names that you need to know for the types of angles. You'll have to identify some of them. So right here, I don't know if you can see this, I've got an example thrown in here in the corner. There's a picture with some points marked and some degree measures written in. It says, find the angle measure and classify. Okay, so the first one says angle RAS. So if I say RAS, it starts at R, goes to A, and goes back up to S. That's what they're referring to. So the measure, you can see it right there, it would be what? What's in between those two sides? 30. So RAS is 30 degrees, and what kind of angle would that one be, Dakota? Acute. Okay, so I'm going to have to write this up here because I can't get this like this. So the measure, that's what the little M stands for, the measure of RAS is 30 degrees, and that makes it acute. So you give the degree, and you also tell what kind it is. All right, now let's go to the measure of angle TAU. So we're starting at T, go to A, go to U. What's the degree measure on that one, Stephen?
90.
90 degrees, and how would you classify that?
Right angle.
Right. Okay, so next we're going to look at angle RAT, or RAT, so RAT. What would you classify that one as? Drayton? Right. I guess I should ask you for the degree measure, but I'm assuming you mean 90 because you said right. Very good. It's also right. Okay, last one. SAU. So SAU. What would the degree measure be of SAU, Tori? 150, because you can add those two together that you know. And what would you classify that as, Tori? Obtuse. Okay, questions about that? Like I said, that part should be reviewed to you. You should know those names already. RAU is 180 degrees.
What about SAT too?
Whoops. Okay, RAU would be 180 degrees because it starts here and goes all the way around. 30, 60, 90. It's a straight line, and you would call it a straight angle. The question was SAT. That one would be, what would the measure be on that one? 60, and you would classify it as acute. Good questions. Anybody else? The last thing that we're going to do then is look at triangles altogether, including the angles, and classify them. Again, this should probably be reviewed to you, the names. Maybe just need a little refresher. You can classify triangles by angle and by side. They get two names. Every time they get two names. So if you're going to classify by angle, you would have to consider all three. It is acute if all three angles are less than 90. Okay, if all three angles are less than 90. It is right if it has one right angle. Could it have two right angles? No, because that'd be 90 plus 90. That's 180. There'd be no degrees left for the third angle, so not possible. And then obtuse, one obtuse angle. So the same thing with that. That's at least 91. There's no way you could have two of them in one triangle. Okay, so that's looking at the angles. You have to decide what the angles look like. And then by side, so let's kind of look at this. Scalene, no equal sides, so it'd be something like this. Okay, none of those are equal. Isosceles generally looks something like this. That almost looks like an equilateral. Hang on a second. Okay, it has two equal sides. One thing I want to tell you about an isosceles triangle, if it has two equal sides, these angles down here would also be the same. Just so that you know that. If it's an isosceles triangle, the angles opposite would also be the same. Okay, an equilateral has all equal sides. And the thing that you need to know about equilateral with all equal sides, it also has all equal angles. And if that's true, how many degrees have to be in each one of those angles then? If all of the angles are equal, what degree measure would each of them have to be? Anybody have any idea? Huh?
Acute. 60.
They'd all be acute, but they'd all be 60 because it'd be 180 divided by 3. These would all have to be 60-degree angles, all of them. Okay? So an equilateral, all sides are equal, and all angles are equal. It's also called something that I'm just kind of telling you for advanced, like when you're in geometry, it's also called equiangular. But you will classify them by side and call it equilateral. Okay, we've got one example. It's this triangle here at the bottom that is not drawn very well. I'm going to make it a little bit bigger just so you can see it. If I can get the thing to come on. Here we go. So it says find the missing angle. Looks like there's a box here, there's a 33 degrees up here, and there's an X here. It says find the missing angle and classify by angle and side. So what you would have to do when you see these problems, you're going to set up your equation. You're going to say 33 plus 90 plus X. How much does that equal to? 180. You're going to go ahead and combine these two. So that'd be 123 plus X equals 180. You can solve for X, subtract your 123. And you're going to tell me X is 57. Okay, now when you go to classify this, don't just go by the 57. You got to look at all three angles. You got to look at the 33, you got to look at the 57, you got to look at the 90, and you got to classify it by angle and side. So, what kind of triangle is it by angle? Tori? It's right because of the right angle. Now, there are no sides marked congruent, but another way you can look at it is if none of the angles are the same, none of the sides are the same. If you've got two angles the same, you got two sides the same, and 3. But if they're all different, all the sides are different. So, Braxton, what would that be?
Scalene.
Scalene. So on those, you have to have three answers. You have to have the angle measure, you have to classify by angle, and classify by side. Questions?